In this video, we're going to divide polynomials using synthetic division. Now, from the last video, remember we can use synthetic division because our divisor is in the form x plus or minus n, and that coefficient of x is 1. Since we have x minus 2, we can use synthetic division here. So let's set this up. We'll draw our table. We know outside our table, we're going to use the x minus 2, and then inside the table is going to be our dividend, this polynomial that we're dividing into the x to the third, plus 3x squared minus 4x minus 10. And we just want the coefficients from this polynomial. We want the 1, positive 3, minus 4, and minus 10. So I'm going to write those down. 1, 3, minus 4, and minus 10. And we want one term on the outside. And we're going to get that from our x minus 2. And that term is whatever makes that x minus 2 equals 0. So let's add 2, and we get x equals 2. So that 2 is going to go right here. I'm going to clean this up a little bit, and then let's go through the pattern that we're going to follow to do our synthetic division. We want to get a series of terms. We want a term here that's outside of our box underneath our first term. Then we want a term here that's underneath our second term inside our box, and then underneath our second term outside our box, and then in the same position underneath the third term and fourth term. So each of these lines are going to have terms on them. So let's go through how we're going to get these terms. And it's basically just a pattern we're going to follow. So this 1 we're going to start with, and we're just going to bring this 1 all the way down. So 1's going to go right here. Now we need to get this line next. So how are we going to get that? Well, we got to take this 1, we're going to bring it up. But when we bring it up, we've got to multiply it by this term on the outside. We're going to multiply it by 2. So 1 times 2 gives us 2. Now we're going to work up with this 3. We're going to bring it down, but there's a 2 here now. So we're going to add the 3 and the 2. We're going to get 5, and we're going to put that 5 on this line right here. Now we're going to continue this pattern. We want this line next. So just as we started with this 1 here, we look at this 1. To get this 2, we're going to look at this 5. To get this blank here, this line here, we're going to bring this 5 up. But we also have to multiply it by this 2 on the outside. So 5 times 2 gives us 10. And let's continue this pattern, right? So now we've got this negative 4. We're going to bring the negative 4 down. Add it. Negative 4 plus 10 gives us 6. We want this term next. We're going to bring that 6 up. Multiply it by the 2. All right, so we're multiplying it by this 2 on the outside. 6 times 2 is 12. And we're going to finish this off by bringing this negative 10 down. Negative 10 plus 12 gives us 2. And we care about the terms that are outside of the box. The 1, 5, 6, and 2. This is going to give us our answers. So here's how we're going to write our answer. Our highest power in the original polynomial that we're dividing into is a 3. We're going to start 1 power lower. So this is x to the third. We're going to start 1 power lower. So this is going to be 1x to the second. This is a positive 5, so plus 5. And this is x to the second, so we're going to have 1 power lower, x to the first, plus 6, plus 2. And this 2, this is going to be our remainder. So I'll put it over. Well, what did we divide by? We divided by x minus 2, so it's going to be 2 over x minus 2, and this is our answer. X squared plus 5x plus 6 plus our remainder 2 over x minus 2. Let's do one more example using synthetic division. Number 2, we've got 5x to the third plus 6x plus 8 over x plus 2. So let's draw our box here. We know that outside term is going to come from the x plus 2, and the inside is going to come from the 5x to the third plus 6x plus 8. Now we actually need to look at this 5x to the third plus 6x plus 8 a little bit closer, right? Let's look at the powers in particular. So we've got x to the third and then x to the first. And we have to have consecutive descending powers, right? So we can't just go 3 and then 1. We have to have an x to the second in here as well, right? So we're going to rewrite this as 5x to the third plus 0x to the second, because if we multiply 0 times x to the second, it's just going to give us 0, plus 6x to the first plus 8. And now when we do this, we've got a 3, a 2, and a 1. We're not just going 3 and then 1, right? So we can't just go 3 and then 1. We've got to put that 0x to the second. The term that we're going to work with here is actually going to be 0x to the second plus 6x to the first plus 8. And then we're going to take the coefficients 5, 0, 6, and 8. And these are the values we're going to use to do our synthetic division. And then we're going to use that x plus 2. Find the value that makes this 0. So subtract 2, and we get x equals -2. So -2 goes out here. All right, now that we've got this set up, I'm going to erase some stuff, clean this up a little bit, and we'll go through our pattern to do our synthetic division. Okay, so remember we need a term here outside of our box underneath our first term, and then we need a term inside and outside underneath each remaining term. So let's start with this 5. We're going to start with the 5, and we're just going to bring that 5 all the way down. So that 5 is going to go right here. Now we want this blank next, that term next, so we're going to bring that 5 up. But we're also going to have to multiply that 5 times -2. So times -2 gives me -10. Now we're going to bring this 0 down, add 0 plus -10. That's going to give me -10. And now we're just going to repeat this pattern. We're going to bring this -10 up. We're going to multiply by -2. All right, because we're multiplying by this term on the outside here, that -2. -10 times -2 is 20. We're going to bring the 6 down. We're going to add 6 plus 20 is 26. We're going to bring that 26 up, multiply it by -2. We're going to get -52. Now we're going to bring that 8 down, add it. -52 plus 8 gives us -44. So the values outside of our box give us our answer. We've got 5, -10, +26, and -44. Now we just have to write in our variables. We've got an x to the third, so we want to start 1 power lower. So we're going to have 5x to the second minus 10x to the first plus 26 minus 44. So this right here is going to be our remainder. So to write our remainder, we're going to divide this last term. So this 26, that's our constant, just our number by itself. Then we're going to have minus 44 divided by what we're dividing. Our divisor here, the x plus 2. So I'm going to put this over x plus 2. Now, if you're confused as to where that remainder goes, right, think about the power on your x's. This is x to the second. This is x to the first. This 26, that would be like x to the 0 power. Once you get x to the second, x to the first, x to the 0 power, whatever you have left, that's going to be your remainder. And if it's x to the 0 power, remember, anything to the 0 power, x to the 0 is 1, 9 to the 0 is 1. Since we have x to the 0 here, we don't need to write in the x to the 0 power. We could just write 26 and get rid of the x to the 0. So answer for this winds up being 5x to the second minus 10x plus 26 minus 44 over x plus 2. So this video was on synthetic division. I hope this video helped you understand this concept a little bit more. If you want to review another video on synthetic division with some introductory examples, you can check out the link for the video that's coming up right now. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.